So remember the product rule, right? It's derivative of two functions multiplied together. What was the product rule? Right? We can use this to build integration. So if I integrate, right, what I end up with is UB equals the integral which we don't know what the integral is already. What we're going to do is manipulate this, move this over here. Okay. We're going to have one single integral left. We're going to this one. We end up with this little formula. This is called integration points. So basically what you have is some integral. Two items, it's like a product rule. It's like the product rule of integrals. And this formula gives you this. Okay, so let me write it out a little bit better on the next page. Here's how your book writes it. Yeah. It really doesn't. This is how it represents an element in the system. So let's say I have some integral like this. Right? It's a product. There's really no way for us to integrate that. We can't use substitute. That's really some of the basic techniques, right? So the question is, how do I apply integration by parts to this? So we have a u and some b prime. Okay. You have to pick those. Now you could go u and b prime. But I'm going to give you some ways to figure out how to choose these. Right? I would pick u equal to x and b prime is cosine x. There's a reason I write offset. It's my organizational broken here. Okay. No chance. Okay. What is the derivative of u? 1. See how it's more simple? And look at u prime is up here. See how we're not going to have to worry about u prime in this integral. So that's when you want to choose a simple u that makes it easier to do an integral. Okay. We need b now, right? What's the integral of b prime? To integrate this to get b, right? Sin x. Okay. Is that more simple? No. Cosine and sine are not. That's not more simple. But it doesn't matter because we don't need it. So, after I've chosen my u's and b's, I can now follow the formula. What's u and b? X sine x minus the integral of du prime. Okay? So we need sine x times 1 dx. Dx's. When I write the formula, I don't write the dx's in there because it's easier to remember. Right. Third out? See you then. All right, now can I integrate sine x? Yeah, what's the integral of sine x? It's negative cosine, right? Any other answer? Times. It's because that's u prime. I didn't want to not put it there. You know what I mean? Yeah, so maybe I should have colored this better. So we have v is sine x, right? We have u is x, u prime is 1. You can see what we've done to eliminate the v prime from consideration. So basically, we're getting rid of something to make it easier. So this here is final answer. It's going to be a run. I know, that's why I said it. It's ironic, isn't it? Okay, I was taught this differently. I was taught it with just a little bit of a different way to write it, and it was easier for me to remember it. Okay. I was taught the integral of u dv, derivative of v, equals uv minus the integral of v du. I don't know why that was easier for me to remember, but it was. It might be better if we use different letters at the SI. But again, our book uses these letters to try to be consistent. You're still choosing U's and V's, similar to choosing U substitution letters, right? But it's just a different technique. Okay. Most of the time, U substitution is undoing the chain rule, right? So you'll have something like that, which has a function, a composition of functions in it, whereas this is only really a pure product rule most of the time. Okay. So, good question, because it can be confusing. So, same formula, I just found it easier to remember. So we have u and v prime and dv are the same. uv minus the integral of v and du. And here you could write du and dv instead. Let's try one more. Every time you do one of these, again, it's really beneficial if you write the formula down, right? So this helps in memorization. what's U prime? 1. Yay! Not always going to be that nice. What is V? So we have what's our first term here? You guys ready with Okay, here's one way. So one way to choose U is to choose something that's going to be more simple. Right? So here's a hints. Choose the U that will U prime or simple. So that's one way. Here's another way. It's an acronym. Yeah, whatever helps you remember, right? Okay, to choose U, first item, so basically you have different kinds of math here. The first one is logarithmic. So if there's a logarithm, it's probably going to be U. Okay. The second one you would want to go to would be inverse trig. Sine inverse x. If there's a sine inverse x in here, you probably want to choose that. Because the derivative of sine inverse becomes an algebraic function, right? The next one will be algebraic, which we've been working with, right? X, that's an algebraic function. Okay, I put this document, this is your comments, trig function so, and then exponential. I put this document on Google Classroom for you, just so you know. It's not what I'm saying here. So it's trig and then exponential. Okay, so if we're looking at this one we just did, we have an algebraic and an exponential, right? What's higher on the list? Algebra, so we chose U as an algebra function. Okay, that's why. Its guideline is not cut and dry. It's a guideline, but you kind of have your idea there. Joke of the day. Choose a U that will do you a favor. I like it. Okay. Let's look at a double integration by parts. Let's use cosine. So if you write a 10, run a trick. Which one we will choose first? So u is x squared. B prime is cosine x. And then work your formula, right? Here, can I integrate that with our old methods? Really? We have to do integration by parts. So yeah, it's a product, right? So choose your letters again. What's u going to be? 2x, which means u prime is 2. Now it's going to work out nicely. B prime sine x. B is negative cosine, right? Now rewrite. We have x squared sine x minus UB minus the integral B so old new integration by parts. Okay, kind of messy, huh? But what you have to be careful of is that you don't mess this up. What's the integral of negative 2 cosine x? Integral of cosine is sine. I think that's just right. And then you will want to simplify it. Distribute your negative. Go off the negatives. That's a double. That's 11 doubles. These have all been indefinite integrals, right? So let's take a look at a definite integral. Have you ever calculated the integral of x? What's the derivative of log natural log? It's 1 over x, right? The integral of 1 over x is ln x.
logarithmic.
Right, okay. It's number one, logarithmic is Li. So U is ln x, B prime is 1. U prime x, B is x. So don't forget your limits of integration.
It's 1 over x times. It's x over 1 times just 1.
Yeah, it's 1. Right, so what's the integral of 1? Notice how I didn't evaluate this yet. I just moved it up to the, in my opinion, that's easier. But you do need to put it there for notation reasons, probably. So now we can evaluate it, right? This is 0, correct? So we have -3 minus -1, which is
I don't know.
I'm pretty sure you do. Doing okay there? It's just adding these limits and then there are possible functions where you can just so let's yeah. Consider this one. So these are, if you see a problem like this, you're thinking, what's the derivative of u dx? What's the integral of u dx? Does it make more sense to do that? Okay, what's the derivative of the sine? What's the integral of sine? Negative cosine. Does it make it any more sense? Are we ever going to be any more sense? No, because your formula has 2 items in here. You're always going to end up with an e to the x to sine x or an e to the x to cosine x. It never gets this. So you can learn to recognize, you better recognize, right, that this will never
When I looked at my college's website, they had the integral from x, sine x, cosine x, and then they had u as x, and then like u is sine x, cosine x, right? And that's where
say that again.
the integral from x,
Of x.
sine x, cosine x. Then
So u is x.
u is x, and then u is sine x, cosine x.
Well, obviously you choose the algebra function first because it makes use of it there. Question is what is b? You can use substitute that. here is the integral of sine x cosine x, right? So choose as a u substitution, choose mu equal to sine x. What du is. Cosine x. So what you really have is the integral of u du, which is u squared over 2, right? So sine x squared over 2. And what you end up with is the integral of ub minus b this you can deal with in some way, shape. That's probably what you're doing. So that's a little bit nasty. Yeah, and this you will probably not see, right? So we would just chalk this away to an opportunity to write something here, and we will work. Okay. That one? That one is good.
Cyclist cycle.
It's like when I
This is when your computer just has that little circle on it, and it just keeps spinning. This is when your calculator goes, ha! Overflow!
Or it's whenever your program.
Error, quit.
Okay,
That's what we're looking at. There is a way to solve that. My brother does not show it to you in the book. It involves doing the integration by parts and using a substitution to backdoor it. Yeah, so it is possible. We're just going to leave it where it is. Exactly. Okay. Okay, here we're in 7.1 now, and we are doing again, most of the problems you see with the new integration techniques you learn are going to be pretty straightforward. Like tomorrow I'll teach you partial fractions. It's not that bad, trust me. But again, we only do linear factors of partial fractions where we can get into quadratics and all sorts of things. So, there you go. Enjoy. If you have any questions, next time.